Today we're going over ancient technologies that we still can't fully explain. And I don't mean like, that's a neat little museum piece. I mean full-on inventions and construction techniques from thousands of years ago that modern engineers, with every tool and supercomputer at their disposal, still look at and go, how did they actually pull that off? Some of this stuff is so advanced it genuinely shouldn't exist yet. And somehow it does. Let's get into it. Number 1. The Iron Pillar of Delhi. It's the 4th century AD, and workers in northern India are raising a solid iron pillar over 20 feet tall in what is now Delhi. Nothing unusual about that on its own. Ancient civilizations forged plenty of iron. Here's the part that breaks people's brains. That pillar is still standing today, out in the open, exposed to rain, humidity, and 16 centuries of weather. And it has almost no rust. Modern iron left outside starts rusting within months. This thing has been sitting there since before the fall of Rome, and the surface still looks nearly untouched. For decades, nobody could explain it. Then metallurgists finally got a close look at the composition, and it turned out the iron contains an unusually high phosphorus content, which reacts with the surrounding elements to form a thin protective layer on the surface. Basically, the pillar built its own rust-proof shield, by accident or on purpose, over 1,000 years before we understood corrosion chemistry well enough to do it deliberately. We still can't reliably reproduce that exact effect today without modern coatings and treatments. Some guy in the 4th century apparently just knew how to smelt iron the right way to make it immortal, and the technique quietly vanished with him. Number 2. Greek fire. It's 672 AD, and a massive Arab fleet is closing in on Constantinople, the beating heart of the Byzantine Empire. They've steamrolled through the region for years, and now they're here to finish the job. The Byzantines are outnumbered, and things look bad. Then the Byzantine ships sail out and unleash something nobody in that fleet has ever seen. Liquid fire, sprayed from tubes mounted on the front of their ships, that shoots across the water like a flamethrower built 1,000 years too early. Here's the terrifying part. This fire doesn't go out on water. It burns on the surface of the sea itself. Sailors who jump overboard to escape it get chased by flames that follow them into the ocean. Entire ships go up in seconds. The Arab fleet is wrecked. That was Greek fire, and for the next 800 years, it was the Byzantine Empire's ultimate weapon. It was so feared that enemy fleets would reportedly turn around at the mere rumor that Greek fire ships were nearby. And here's the thing. Nobody alive today knows the exact recipe. It was one of the most tightly guarded state secrets in history, known to only a handful of people at a time, and it died with the empire when Constantinople finally fell in 1453. Modern chemists have thrown centuries at this. The leading guesses involve petroleum, pine resin, sulfur, and quicklime, but nobody has managed to recreate a substance that checks every historical box, sprayed through tubes, ignites on contact with water, sticks to surfaces, and can't be put out. Some of those properties basically fight each other on paper. The Byzantines built one of the deadliest weapons in ancient history and then, on purpose, let it disappear forever. Number 3. Damascus Steel. Sometime in the early Middle Ages, swordsmiths in the Middle East started forging blades unlike anything the world had seen. These swords could reportedly slice through European blades like they were made of tin and cut a piece of silk clean in half just from the fabric drifting onto the edge. The surface had these swirling, water-like patterns, and it turned out that wasn't decoration. It was a signature of something happening deep inside the metal. Fast forward to 2006. Scientists in Germany put a fragment of a genuine Damascus steel blade under an electron microscope and found carbon nanotubes. Microscopic cylindrical carbon structures that are among the strongest materials known to modern science. We consider carbon nanotubes cutting-edge nanotechnology, and we only discovered them in 1991. Medieval blacksmiths were apparently forging them into weapons 800 years earlier, with zero concept of what an atom even was. The technique died out around 1750 when the specific or used ran dry or trade routes shifted, and it's been lost ever since. Blacksmiths have spent decades trying to recreate true Damascus steel, and while some get close, nobody has matched the original in both structure and performance. We can launch rovers to Mars, and we still can't outforge a 12th century blacksmith working with a furnace and a hammer. Number 4. Roman concrete. The Pantheon in Rome was completed in 125 AD. It still holds the record for the largest unreinforced concrete dome on Earth. It has survived nearly 2,000 years of earthquakes, floods, wars, and just plain time. You can walk in and stand under it right now. Meanwhile, modern concrete, the stuff holding up our highways and parking garages, starts breaking down after about 50 years, and we spend billions every single year just trying to keep it from falling apart. For a long time, nobody understood why Roman concrete held up so much better. We knew the basic recipe: volcanic ash, seawater, lime. What we didn't know was why it got stronger with age instead of weaker. Then in 2023, researchers at MIT cracked part of the puzzle. Roman concrete contains small white mineral chunks called lime clasts, which scientists used to assume were just flaws in the mixing process. Turns out they're the opposite of a flaw. When the concrete cracks and water seeps in, those lime clasts dissolve and recrystallize, sealing the crack from the inside. The material patches itself. Seawater, the exact thing that destroys modern concrete, actually strengthens the Roman version. Engineers are now trying to reverse engineer this for modern use. But the specific volcanic ash the Romans used only exists in one region of Italy, and it's proving brutally hard to replicate with what we have today. So for now, the Pantheon just sits there, casually outlasting nearly every building constructed in the last 100 years. Number 5. The Antikythera Mechanism. It's 1901, and Greek sponge divers are exploring a shipwreck off the island of Antikythera. The ship went down around 65 BC. Among the statues and broken pottery, they haul up an unremarkable lump of corroded bronze and toss it in a box. Months later, in a museum, someone notices the lump has cracked open, and inside are tiny bronze gears, dozens of them, precision cut, interlocking, inside a device over 2,000 years old. What they'd stumbled onto was essentially an ancient analog computer. At least 30 bronze gears working together to predict solar and lunar eclipses, track the 5 planets known at the time, calculate the timing of the Olympic Games, and model the moon's irregular orbit, which requires seriously advanced math. After this device was built, humanity would not produce anything close to this mechanically complex for another 1,400 years. That's the equivalent of digging up a working laptop out of a Viking burial mound. It just should not be there. Scientists have spent over a century X-raying it, CT scanning it, 3D modeling it, and they still can't fully replicate the thing. We understand what it does. We mostly understand how. What still stuns researchers is the sheer precision of those gears crammed into a box the size of a shoebox. And here's the unsettling part. It was found on a ship, meaning it was being shipped somewhere, like it was routine cargo, which means it likely wasn't a one-off. How many more of these are still sitting on the ocean floor? Now for the supporting cast. These are shorter, but just as unsettling. The Baghdad battery. Around 250 BC in Mesopotamia, someone built small clay jars containing a copper cylinder and an iron rod. When modern researchers filled a replica with vinegar, it produced about 1.1 volts of electricity, roughly 1,800 years before Alessandro Volta gets credit for inventing the battery. Some historians think it was just a storage jar and the electrical effect is coincidental. But that's a suspiciously specific arrangement of copper, iron, and acid to stumble into by accident. The Lycurgus cup, a Roman glass cup from the 4th century that changes color depending on how the light hits it, green when lit from the front, glowing red when lit from behind. Scientists eventually found the glass contains gold and silver nanoparticles, sized around 50 nanometers. That is genuine nanotechnology, embedded in a drinking cup, over 1,000 years before we had the tools to even see nanoparticles, let alone understand why they behave that way. Sacsayhuamán. High above Cusco, Peru, the Inca built fortress walls out of limestone blocks weighing up to 130 tons each, fitted together so precisely you cannot slide a piece of paper between them. No mortar, no cement, just stone locking into stone like a puzzle. The whole structure has survived over 500 years of earthquakes in one of the most seismically violent regions on the planet, and we still don't have a confirmed answer for how they cut and moved stones that size with the tools they had. And finally, Pumapunku, a temple complex in Bolivia sitting nearly 13,000 feet above sea level, built from andesite and diorite, 2 of the hardest stones on Earth. The blocks have perfectly flat surfaces accurate to fractions of a millimeter, uniform drilled holes, and interlocking pieces that fit together with the precision of Lego bricks. This was built by a civilization with no iron tools, no steel, and as far as we know, no writing system. Modern engineers have said they'd struggle to match that precision with today's equipment. So there you go. Technologies our ancestors built thousands of years ago that we either can't explain, can't replicate, or flat out can't believe existed in the first place. An iron pillar that refuses to rust. A weapon so effective its own inventors erased it from history. A sword hiding nanotechnology we only rediscovered in the 90s. And concrete that heals itself while our modern version crumbles in half a century. Makes you wonder what else got lost along the way. How many discoveries were made, used for a few centuries, and then quietly forgotten? How much did ancient civilizations actually understand that we're only now catching back up to? I don't have an answer. But next time somebody digs up a weird lump of metal from a shipwreck, maybe we take a much closer look before we toss it in a box.